Okay, so before we start on the actual notes, we're just going to talk through something that we've already done. I don't always write it down like this, so I want you to think about what's happening. If I wanted you to find the sine of theta, all right, and I said that theta is 7 pi 6, right? So that means I want the sine of 7 pi 6, yes? Something that we know and we understand, right? So usually the way I talk you through this and the way most of our minds probably work, I realize that yours may work a little bit differently, but the first thing I usually ask you is, what is the reference angle? What is my first quadrant angle that refers to 7 pi 6? What would my first quadrant be? Pi 6, okay? So that means even though theta is 7 pi 6, our reference angle is alpha, it's pi 6, right? And then we know that theta, which is 7 pi 6, which would be in what quadrant? The third, right? And so theta is here in the third quadrant. So then I ask you, what is the sine of pi 6? 1/2, right? It's just sine of pi 6 is 1/2 because we start there, right? And then we say, okay, we know sine is negative in the third quadrant. That's what makes it negative 1/2, right? Like I said, you don't have to write any of this down. I just want you to, that's how we've been thinking around the unit circle, right? So we're going to do the same type of thing, but I don't usually like write it down or call it alpha. But we did when we first talked about reference angles. But we think about everything revolves around alpha. If we know our first quadrant, we figure everything else out, right? All right, so then we go to think about things in terms of decimals. So the reason we're going to need a calculator here, and this is going on 107, is because we're going to have to take the inverse. Like if I took the sine inverse of 1/2, I know it's pi 6. If you had to take the sine inverse of 2/3, you have no idea what that is. That's not a special angle. You're not expected to know. That's why we're going to use the calculator, okay? So on here, we know that we go from 0 or 2 pi. Then we know that this is pi, and this is pi halves, and this is 3 pi halves, right? So if we think about, this is alpha, your first quadrant angles, they're all your reference angles, those are your alpha, right? So what we've been doing is we've been saying, okay, we're at 0, I need my third quadrant pi thirds angle. So we get here and we think, okay, this is 3 pi thirds, I go forward 1, I get 4 pi thirds, right? Or 3 pi thirds, I back up 1 and I get 2 pi thirds. So basically what we're doing is we're taking pi and we're subtracting alpha, or we're taking pi and we're adding alpha. Make sense? So that means for second quadrant for all of them, basically it is pi minus alpha, and this one is pi plus alpha. We just don't talk about it as pi, we talk about it as 3 pi thirds or 4 pi fourths or that type of thing, just to make it make more sense. So then for our fourth quadrant, we get all the way to 2 pi, so if we're still doing thirds, this would be 6 pi thirds, and we subtract 1, right? Or 11 or 12 pi 6 and subtract 1, whatever it is. So that means this is 2 pi minus alpha. So these rules here that we need for the calculator, I don't want you to think of it as a brand new set of rules. That's what we've been doing, right? We've been doing those exact same things. We just might talk about it a little bit differently. One of the things that these aren't numbers that you absolutely just have to know, but to help you make sense of what's going on here. We know that, this is 0. So pi, decimal-wise, is like 3.141 ... right? So that means that pi halves is half of that, which is about 1.5, right? So it's really 1.570, blah, blah, blah. I'm not saying, again, that you have to know what these are. Like for E, you kind of need to know what it is, just basically, or even pi, you kind of need to know what it is. But these is just to kind of help you make a reasonable decision here. So if this is about 3, this is about 1.5, which means this would be about 4.5, right? It's really like 4.712. That doesn't look like a 7. 712. But thinking about it is about 4.5 is really usually good enough, right? So if this is about 1.5, about 3, about 4.5, this is about 6, but it's really either 0 or 6.28, blah, blah, blah. Just so that, we know if we have 7 pi 6 that we're in the third quadrant. Well, if I give you a number like 4.1, you would know that you're in the third quadrant. And again, not that you always just have to know that, but when you get your answers to see if your answers are reasonable, I think it just kind of helps to be able to think about the decimals at least. Okay, we good on that? All right, so if we can do all that, I'm gonna do this a little bit differently than I did last period because we got all kinds of lost on this calculator. If you are going to store things on a TI like the 83s and 84s that I know that you use sometimes you have to push the alpha key. We're not pushing the alpha key here. Okay, we're going to store some things real quick. I want you to just push the number 5. We're going to store 5, okay? So in order to store that, we're going to do shift. Right above 7, you see where it says recall? It says STO in yellow, that's why we're using that. Shift, store, and then we're going to store it in A. You don't hit alpha, you don't hit anything else, you just hit the negative sign. You see the red A there? And it should say 5 with an arrow to A. You see that? And then you hit equals, okay? So we stored 5 in A. So again, just hit the number 5. You do shift, recall, which is really the yellow store, the negative sign, which is really the red A, should say 5 arrow A, and then you can hit equals. Okay? The only time that you would need to use the alpha key on this calculator is if you want to see if you actually stored it, right? So if you clear your calculator off where you see nothing, if you then do alpha and hit A and hit equals, it should say 5. If it does, you're good and you stored it correctly. If you need help, let me know. Okay. So 5, shift, recall, negative for the red A, and then hit equals, yeah. All right, so now if you clear it off, then you can just do alpha A, and it equals. Okay, are we all good? We got a 5? Yep, and so then just hit clear, and then do, or just like the AC, it's fine. And then hit alpha, A, hit equals. Okay. So every now and then you might want to hit alpha A just to make sure that you had it stored correctly, like if your numbers are looking weird. Other than that, when we store and when we recall, we do not hit the alpha key. Okay? So we're going to add something to A. We're going to do, I want you to type in 10 plus, then recall, which is right above the 7, negative sign. So it should say, literally say 10 plus A in your calculator. You hit equals. What should we get? 15. We all get 15? The hardest math of the day, okay? Just making sure that we understand the buttons, right? I'll talk you through them every time we do it. I just want to make sure without all the other stuff going on that we get this. Because it's been a while. We've stored before, but it's been a while. Okay, are we good? Okay. And just be mindful, if you're going to use a different calculator at some point, that's totally fine. Just the steps might be a little bit different, right? But we all love these calculators, I know. Okay. So we're going to solve this trig equation on the interval from 0 to 2 pi to the nearest thousandth. How many decimal places is that? 3. You always go to 3 unless you're told otherwise. All right, so we have to solve this equation. It's not a quadratic. I don't see any need to factor. This looks like I just need to get sine of x by itself, right? So I'm going to subtract 1 from both sides. You get 5 times the sine of x equals negative 1. So then the sine of x is equal to negative 1/5, which means x is equal to the sine inverse of negative 1/5. Do not touch your calculators yet, because I guarantee you will do it wrong. Okay? Because that's not what we're typing in. So since I want the sine inverse of negative 1/5, that's telling me that my sine value is negative. So I need to think about what quadrants is sine negative in. What quadrants is sine negative? Third and fourth. Okay, so these are the 2 quadrants that I'm using, which means that I'm going to find alpha. That's what I'm going to get out of my calculator. But then once I find it, I'm going to be in the 3rd quadrant, which means I do pi plus alpha, and then I do 2 pi minus alpha. And that's where my actual 2 answers are going to come from x. We all good with that? Okay, so here's the catch of the calculator. Even though this is what we are finding, and this helps us know what quadrants we want, that is not exactly what we're typing in. So I want you to write this down. Always use positive numbers in the calculator. And then I'll explain to you why. Is there other ways to do it where we wouldn't have to do that? Yes. But Here's why we're going to do this, so that we have one way and we don't have to reason our way through everything a million times. If we're just going to do straight up inverses, which is what the calculator is going to do for you, then when we take the sine inverse, we know we're going from negative pi halves to pi halves, right? Which means this is going to give me an answer somewhere down here, which is fine because I actually want a fourth quadrant one, right? But do I want it to be a negative angle that it gives me? I don't, right? And so then if it gives me a negative angle, I can't do 2 pi minus alpha. I'd have to, I could add 2 pi. Like, I'm not saying we couldn't get there, but I'm saying if we want something consistent to be just like everything we've done before, we want to find alpha. And this negative angle is not alpha. Alpha is your first quadrant angle that's going to be your reference angle, okay? So in order to get our reference angle, again, we still write this down because in the end, this is what we're finding, but we're going to find alpha in the calculator, which means you actually do the sine inverse of a positive 1/5. So in your calculator, do sine inverse 1 divided by 5. And then I always write down 0.201. I at least write down a few decimal places just so I have an idea of what's going on. That is a first quadrant angle, I know for sure, because that goes from between 0 and about 1.5-ish, right? All right, so now I'm going to store this. So does everybody have 0.20135, blah, 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 looking at them? So we do shift, recall, negative sign, which should store it in A. We good? Okay, so now that I have it stored, I can go find my x. X equals. So I'm going to do pi. Pi is down, it's yellow, so we have to do the shift, and it's on the very bottom row in the middle. So shift pi plus alpha plus, then I just do recall A. Do not hit the alpha key. So your calculator should literally say pi plus A. Then you can hit equals, and you should get 3.43. No, 3.4. Oh, I missed it. 3.3. Oh my gosh, I cannot even read off the calculator. 3.343. Sorry. Okay. Anybody having issues getting that number? Don't be afraid to speak up because if you did exactly those steps and you didn't get that number, then maybe you didn't store it. Maybe it isn't that these steps are wrong. So go ahead and let's try the next one, and then I'll come around and see if we need to do. We're going to do 2 pi minus alpha. So I literally do 2 pi minus recall negative sign. So my calculator says 2 pi minus A. And I get 6.082. And those are my two numbers. And this is between 3 and 4.5. This is between 4.5 and 6-ish, so that looks like third and fourth quadrant angles for me. Okay. Anybody need my assistance? Are we all good? Okay. Hopefully the trig makes sense to you because we've been doing that. It's just the calculator pushing us. So we got to make sure we got that right. We're all good? Perfect. Okay. Let's go to the next one then. All right, so I've got 5 cosine of x equals 2 secant x. I'm mixing trig functions, and they're not being multiplied, so that usually is not going to work out very well for me, which means I need to change something. What is secant the reciprocal of? Cosine. Okay, so let's make this into 5 cosine x equals 2 over cosine x. Or 2 times 1 over cosine. It doesn't matter. It's the same thing either way. Okay. Thank you. Go grab your calculator. All right, so then what do you think we could do next? Can I get my cosines together? Yeah. So can I multiply both sides by cosine, you think? So that'll give me 5 times cosine squared x equals 2. Then I can divide by 5, so I can get cosine squared x equals 2/5. Then I can take the square root of both sides, right? So what does cosine x equal? Plus or minus the square root of 2/5. And that whole fraction is under the square root. I do not care about rationalizing or anything because we're about to use the calculator, right? So there's no need to do any of that. So that means that I have cosine inverse, or x equals the cosine inverse of plus or minus the square root of 2/5. So since I have plus or minus, and I am doing from 0 to 2 pi, that means I'm going to use all my quadrants. So I'm going to need alpha, pi minus alpha, pi plus alpha, and 2 pi minus alpha. So to find alpha, I'm going to do the cosine inverse of just the positive square root of 2/5, making sure that the 2/5 is all under the square root sign, right? So I'm going to do cosine inverse. I'm going to hit the square root key, then I'm going to hit the fraction key because that'll make me feel better that everything's where it's supposed to be because I can actually look at it like that. Oh, I did cosine instead of cosine inverse. Cosine inverse, square root of 2/5. And I get for alpha 0.886, something. So then I'm going to store it. Shift, recall, negative sign. So it should say answer with a little arrow to A, meaning that I stored it. And then I'm going to find the rest. Okay, so I know that for my first value, it is alpha. It's 0.886. Then I'm going to do pi minus, recall negative, and then pi plus, so go ahead and find the rest of them, and then I will see if anybody needs assistance. Anybody need calculator assistance? Make sure that you're actually pushing the buttons, which looks like most of you are. Don't just write mine down. I want to make sure that you can find them as well. Anybody having calculator issues? Don't be afraid to speak up. You good? Yes? All right. Everybody else good? Yes? Yes? Okay. Some of us are still writing. That's fine. Go ahead. I want you to go. I want you to have time to find them on your own. Okay, are we good? All right, so let's look at number 3. So I have sine and cosine and mixing my functions again, not being multiplied, so I can't use the reciprocal idea like I did in number 2, but I know that sine and cosine, when it's not squared together, can give me what? Tangent. Okay, so do I want to divide both sides by cosine or by sine? Cosine, because we want to have sine over cosine, right? So if I divide both sides by cosine, I'm going to get 4 equals -7 sine x over cosine x, right? Or -7 times that. I could have written it the other way, which probably makes a little bit more sense to most people, but it doesn't matter. All right, so then I know sine over cosine is tangent, so 4 equals -7 tangent x. So to get tangent by itself, I'm going to divide by -7, so -4/7 equals tangent x. So x is equal to the tangent inverse of -4/7. All right, so remember, in the calculator, we're going to put, and that doesn't look like an inverse, we're going to put the positive, but we write down the negative because that's what we're actually finding. But that tells us what quadrants we need, right? So when is tangent negative? The second and the fourth, right? Which means we're going to do pi minus alpha and 2 pi minus alpha. Right, so then in the calculator, we can find alpha. So we do the tangent inverse of 4 divided by 7, positive 4 divided by 7, which gives me 0.519, blah, blah, blah. I'm going to store that. Shift, recall, negative. And then I'm going to do my pi minus alpha and 2 pi minus alpha. Those are the two numbers that you should get, so make sure you get those numbers. Let me know if you have questions. Any questions at all? Anybody having calculator issues? Don't be afraid to speak up. I can't help you if I don't know if you're having issues. I actually don't even have your calculator. Go get your calculator. And so remember, the only time you might want to use the alpha key is like if you get funky numbers. Well, if you don't match mine, then you know. But if you're doing it on your own, you don't necessarily know, except that if you know you're supposed to have a second quadrant angle, and when you do that, you get something else weird, and you know it's not right there, then maybe you need to check it. Or if it's the exact same number as the question before, maybe you didn't actually store it. So you could just do, clear it off and do alpha A and hit equals, and then you could just double check that it matches that. That's one reason why I write it down. But again, you don't necessarily have to. Any questions at all? We're all good? All right, so then let's look at number 4. Okay, so I didn't tell you to get your yellow cards out, but that's okay. We should at least know, is tangent squared related to secant squared somewhere on that chart? Yes. I mean, you've used it enough by now. You should know that when in the Pythagoreans, tangent and secant is related. And if you're not, and there's a +1 in there, but you don't know exactly where it is off the top of your head, that's okay. As long as you would know to look for that, I'm just going to tell you what it is. You don't have to dig it out right this second. So on here, what this actually says is tangent squared plus 1 equals secant squared. So since I want to replace this, I'm going to make that into 2 times. That would be secant squared minus 1. So secant squared beta minus 1, parentheses because there was 2 terms, equals 7 secant beta minus 8. So I will distribute and get 2 secant squared beta minus 2 equals 7 secant beta minus 8. Okay. So then I have a quadratic, which means I want to set it equal to 0. If we're super lucky, the squareds cancel out. If we're just at least kind of lucky, our squared term is, the coefficient is 1. We're not going to be lucky at all in either one of those aspects here, but that's okay. So we get 2 secant squared beta minus 7 secant beta plus 6 equals 0. So my squareds didn't cancel out, and A is not 1, and I don't have a GCF. I'm still going to have to factor, but I'm going to factor by grouping, right? And it's the exact same process as factoring by grouping if we were doing if this was just x squared and x here. So I'm going to do 2 times 6. That gives me 12. So two numbers that multiply to give me 12 that combine to give me a negative 7. 3 and 4. So 2 secant squared beta minus 3 secant beta minus 4 secant beta plus 6 equals 0. Okay, so out of these first two here, I can just factor out a secant beta. That leaves me with 2 secant beta minus 3. What can I factor out of these two? Negative 2. Good. Negative 2. That leaves me with 2 secant beta minus 3. That's what I was hoping for. Those match, right? So then that gives me secant beta minus 2 times 2 secant beta minus 3 equals 0. Then I'm going to do my zero product property here. And this gives me secant beta equals 2. What is secant the reciprocal of? Cosine. So really this is cosine beta equals 1/2, right? And then here I would have 2 secant beta equals 3. So secant beta equals 3/2, which means cosine beta equals 2/3. Everybody good so far? All right, so I'm going to move up over here so that we can. So what I have here then is that I have that so beta is equal to the cosine inverse of 1/2, and beta is equal to the cosine inverse of 2/3. So in both cases, that's positive, right? And when is cosine positive? First and fourth, good. So that means I'm going to use alpha and 2 pi minus alpha. So here, when I want the cosine inverse of 1/2, I don't need the calculator. That's a value I know. So I want to be able to actually do that without the calculator. What is the reference angle for when cosine is 1/2? Pi 6. Good. Which means that beta is pi 6 and what? Third. Oh, it is pi thirds. Sorry, I heard pi 6. And I was like, yeah, no, it's pi thirds. Thank you. We're paying attention here. It's pi thirds, yes. That's our first quadrant angle. So beta is pi thirds. And what's our fourth quadrant pi thirds angle? What's 6 pi thirds minus pi thirds? Right, so it's 5 pi thirds. Good. Now for this one, we're going to need the calculator, right? So my alpha here, I'm going to do the cosine inverse of 2/3. Cosine inverse of 2/3. That gives me 0.841. So then beta would be 0.841. And I'm going to store it and then do 2 pi minus alpha. Now, if you only have to use it once, you don't necessarily have to store it. You can manipulate the calculator. But more often than not, when I choose, I don't have to store it. Then I hit the wrong key somewhere, and I have to go back and retype everything in. So I always just store it just to be safe. 5.442. We good? Okay. So although I know that you have a calculator in front of you, and you could totally do this with figuring out the decimals, we're going to reason our way around the circle instead. And we want to reason our way around, okay, we've got to put these betas in order from least to greatest. Okay, so I know one of these two has to go first. Okay, so pi thirds is like, it's in the first quadrant somewhere. let's say that this is pi thirds. I know it looks more like pi fourths, but it really doesn't matter. I just have to decide if 0.841 comes before or after that, right? So if I just think logically, pi is about 3, right? It's a little bit more than 3. If I divide that by 3, I get a little bit more than what? 1. So pi thirds is a little bit more than 1. So does 0.841 come before or after it? Before it. It would come right here, right? 0.841. That makes sense? Just a little bit of logic. So I've got 0.841 and then pi thirds. Then I go all the way around to the fourth quadrant. So pi thirds is here somewhere, right? But then what we know about the unit circle, I don't have to think about decimals anymore. What I know about the unit circle, that's 5 pi thirds. What I know about the unit circle and its reflections and its symmetry, would 5.442 come before or after that? After that, because this would reflect down here and this would reflect here, right? So this would be my 5.442 right there, just based on what we know about the circle. Make sense? So then the next is 5 pi thirds, and then 5.442. And again, I know you could have typed in the decimals and seen which was greater or least, but I want you to just be able to think about those things as well. Okay. What questions do you have? We good? Okay. Tomorrow, you're going to have a quiz on 5.8b. We did that last Wednesday. I know I was out on Thursday and Friday, but you had time to work through it and talk through it together and check yourself. I know you can't really ask questions, but if you have questions, we have some time left, and I'll be happy to answer those for you so that we can do our quiz. And then I wasn't planning on giving you tomorrow to work through the rest of, work through the assignment that I'm about to give you, but I am going to. That way you can use the calculator, can make sure, especially since I wasn't here to answer some questions on the others, that you can get it done and you know what's going on. Okay? Are we good? Perfect.